Hello everyone, I'm Manopna, currently studying BTech third year in NIT Andhra Pradesh. This video is about my course project of EC312 Optimization Techniques. In this video, I will explain about one of the Newton's method application, logistic curve fitting. Newton's method is an algorithm that can be used to optimize a function by iteratively improving the initial guess of the solution. The method is commonly used to find the minimum or maximum of a function. In logistic curve fitting, the goal is to find the values of the logistic functions parameters that best fit the observed data. The basic idea is to find minimum or maximum quadratic approximation of that function and taking that point as the next point for the iteration. This mainly depends on first and second derivatives of that function at the current point. The algorithm starts with the initial guess by iteratively improving this to get the convergence point by using gradient and Hessian matrix of the function at the current point. We reach the convergence when the absolute error reduces to zero or become less than the tolerance. Logistic curve fitting is the process of estimating the parameters of the logistic curve, which is known as sigmoid function, which is defined by 1 by 1 plus e power minus beta naught plus beta 1 into x. Here beta naught and beta 1 are the parameter values that have to be guessed to fit in the best logistic curve. To estimate the parameters of the logistic curve, we use maximum likelihood estimation, which is a common method for estimating the parameters of a probability distribution based on observed data. The goal of maximum likelihood estimator is to find the parameter values that maximize the likelihood function or equivalently minimize the negative log likelihood of the function. The parameters of the model are the intercept and slopes of the predictor variables, that is beta naught and beta 1. Maximizing the likelihood function allows us to estimate the intercept and slopes that best fit the data and give the best fit logistic curve for the given data. In minimizing the given cost function, we also use a L2 regularization. This adds a penalty term that encourages the model to have smaller parameter values. This penalty term is proportional to the squared magnitude of the model parameters. This strength is mainly controlled by the hyperparameter called lambda. This mainly prevents overfitting and improves generalization performance so that we can reduce the impact of less important parameters on the model's prediction and prevent overfitting. Finding the beta naught and beta 1 from this cost function and plugging the values into the logistic curve or the sigmoid function gives us the best logistic curve for the given data. By finding Hessian matrix and gradient of the function, we compute new theta values until convergence occurs. These parameter values maximize the likelihood function. This is the code that shows how Newton's method helps in finding the best fit logic curve. We taken some x and y data and we also added some random noise to the data so that we can distribute the data. We added the intercept down here, that is beta naught. We set the initial values of theta and other parameters like theta, that is beta naught and beta 1, and lambda, that is the regularization coefficient, that is 0.1. We have taken a maximum iterations of 100 with tolerance of 10 power minus 6. The sigmoid function, that is 1 by 1 plus e power minus beta naught plus beta 1 x, is defined by this in terms of set. This is the cost function that we have already discussed. It constitutes of negative log likelihood and a regularization term. The gradient of this function is defined as this, and this is the Hessian function of the cost function. Now we are performing the Newton's method. For each iteration, we are finding a new theta value, that is beta naught and beta 1, that minimizes the log likelihood function. These theta values can be found by using the Newton's method formula by Hessian matrix and the gradient of that function. We can stop the convergence when the absolute error is less than the tolerance. We can break them and give the points as the best fit points for the logistic curve and plot against the graph. This is the result that we are getting. For these data points, the best fitted curve can be found by using the Newton's method by finding beta naught and beta values, parameter values that fits the given data. This is the code that I have written. how I am getting my best fitted curve. This is the best fitted curve that I am getting from my different data points that I have given. This curve changes every time because I have added some random noise there. But it gives the best fitted curve every time we run it based on the given data. So we can say that Newton's method is a very fast optimization algorithm, and also it is sensitive to the choice of initial guess. The accuracy and the reliability of the logistic curve fitting depend on the quality of the data, the appropriateness of the model assumptions, and the choice of fitting method. These are the differences that I followed for the logistic curve fitting. And thank you.